Hello everyone. It is Winter Data Meetup from datazencommunity. Our speaker is Nikolay Kurbatov, and he will tell us the whole truth about data science, about its power and weakness, what it can and what it can't. Please don't hesitate to ask your questions in YouTube chat. Hi Nikolay, it's so nice to see you here. The floor is yours.
Hello, everyone. Thank you so much for joining me today. So hopefully this talk will be beneficial for at least most of you. So, right. Okay. Without further ado, let's start. So my name is Nikolay. I've been with EPAM for about 2 years now. And today I will present solving data science business challenges. Actually, within 7 big challenges which I have been facing throughout my career before and at EPAM as well. And the agenda would be the following. So first we will discuss what the data science is about, then briefly cover the difference between data science and software engineering. Then, as I said, we will discuss these challenges from 1 to 7. Then key points, actually the most important slide is key points. I would really encourage you to save it or make screenshots. And then, of course, question and answer section. So, right, let's move forward. All right, what is data science? Well, as you can see on this Venn diagram, data science is an interdisciplinary field that connects computer science, math and statistics, domain and business knowledge. Also, we cannot discard software development and as well as traditional research. So that is the reason why if you will Google what data science is, or probably ask ChatGPT, right, you will see lots and lots of different answers. But the main idea is that will always is, and I think be, an interdisciplinary field which connects a lots of other fields. So, and yeah, so okay, so data science doesn't equal software engineering, although it cannot live, to my mind, without it. The difference between data science and software engineering projects could be very substantial. So, for example, data science project cannot live without the data, in contrast with software engineering, because you can literally start without any data whatsoever, speaking about software engineering. Also, data science project focuses on exploration and discovery, such as probably heard that before, finding an insight in the data, identifying data sources which could be used for the model training and so on. And then also important part about data science project which distinguishes it to software engineering is domain focus, because project which is powered by data science in healthcare would be vastly different to the project which is powered by data science in automotive industry, in retail, or any other. That's why, as I pointed out before, domain expertise is a part of the data science as well. And also, one of the important part is that data science cannot be, as I said, think without data, but it also connects with the code. In contrast, software engineering, projects are heavily code oriented. So this is, it's not, of course, the full list of the differences, but to my mind, this, brief 3 parts on one point and 3 parts on the another should give you a brief overview of how they differ. So actually, that's also very important and very interesting figure. I think right now it's probably the same. So unfortunately, approximately 80% of all data science projects never make it to production, due to not only the challenges which I will tell you today about, but also due to some other difficulties. But basically, numbers are not so good. They're kind of progressing towards less drastic number than 80%, but still, unfortunately, number of projects which make it to production is relatively low, and we are actually at EPAM working to increase that number to make it much more better. So, all right, now speaking about the challenges. So, challenge number 1, simple, right? Business hypothesis first, and sounds simple, but unfortunately, it's not. So, I have encountered a couple of projects that has been starting the task using the data, meaning that they start solving the task using data without any hypothesis whatsoever. I mean, business one, which actually could be translated into, having a baggage, collecting a baggage, packing the baggage to go to vacation, for example, but without specifying to which location you will go. So if you will go to Hawaii, that would be one type of package, right? If you go to Alaska, completely different, right? So that's kind of a very bad and ugly analogy, but still works for most of the cases. And actually, there is a solution to that. It's quite simple. You start and validate hypothesis first, and then you look for the data which will prove that the task is actually solvable. So to my mind, that's the first and not foremost, but the first thing is, which is quite easy to start to and easy to actually solve with the correct approach. Second problem is that one size fits all. So here, there is a kind of misunderstanding that there is one, golden algorithm which will rule them all, or which will solve everything, which is unfortunately not true. So there is no magic algorithm, and the solution to that is an algorithm is just a tool which should be tailored to the business hypothesis at hand, meaning that each business hypothesis has its unique requirements. Hence, you have to choose a tool, meaning algorithm, accordingly. And probably one additional piece of advice is to probably use Ensemble as a stack of algorithms used. But basically, yeah, that's the one. So third one, as I started regarding the data on the second slide, the data is vital. Lack of data to solve, and there are lots of issues. Then there is actually you for example, you have completed the business hypothesis as well, but then you stumbled upon that there is no enough data to prove that this hypothesis could be solved through the data science. So and for data for the data science kind of a fuel for the cars. So without fuel, your car couldn't ride. Neither data science project could be succeeded. So and the potential solution to that is to start the data analysis task before the actual development, so that the team of data scientists will actually understand which data source they will use, and within that source, if the data presented is enough. That's important. Now, okay, business versus technology, challenge number 4. So here, there are sometimes there is a misunderstanding between business metrics versus data science metrics. It means that while developing data science models, the development team or data science team could focus more on statistics, math, you name it, evaluation metrics of the model, which rather than business one. And that actually this solution to that problem is, to my mind, probably in the top 3 of the ones in terms of the efforts to be solved. So they are this problem is very hard to solve, unfortunately, because sometimes there is no direct way how to map model results, model evaluation metrics such as ROCALC, F1 score, accuracy, whatever you name it, to, for example, churn rate, right, a business metric, or average revenue per user, or any other metric you can think about it. And potential solution to that is to use business metrics for the model evaluation when possible, and in other cases use proxy metrics. And actually that task, to find the proxy metric is, as I said, one of the most challenging tasks for any data science product owner, product manager, as well as any data scientist in the team as well. So yeah, I would encourage you to look very detailedly into that challenge as well as others, but this one could potentially pose a lot of difficulties along the ride. So next one is probably obvious, infrastructure, right? So there are numerous cases I've been encountered. Then there were lack of infrastructure. I mean, specifically data science infrastructure, right? Data science infrastructure, should be in place to run a model on real data, and without it, and without this infrastructure, model still could be deployed, but the cost of maintenance for the development team could be very high. So basically, the potential solution to that is to design data science infrastructure after the business hypothesis and data steps have been solved, meaning that business hypothesis has been, taken into account, has been written down by the product owner or product manager, then data which is sufficient to prove that this business hypothesis could be solved has been found, has been labeled if needed, right? And then this task, could be done in chunks as per priorities as well. So next one is communication. Gap in communication between teams is very much real problem, because business and development teams oftentimes speak different language, and that's perfectly fine. Not fine, then there are unrealistic expectations from the development team and failure to deliver due to technical constraints in the business context. The solution to that is also could be look like pretty simple. Data science projects should have clear roles. Also, by clear roles, there should be definition between MLE, which is machine learning engineers, data scientists, data science product owner as well. And business stakeholders should receive, communication in a business context, not a technical one. That's very important, because if you will do that, business stakeholders, kind of messages in terms of, okay, we have received our ROCALC score equals to something, it will mean probably nothing to them. So you have to adjust your communication to the team members as well. That's all about communication. And yeah, challenge number 7 is future planning. Sometimes there are no plans of how data science project will live on production. And the lack of go-live roadmap for data science project could result actually in a wasting of development teams' resources in the long run. Well, it almost always does. So the potential solution to that is to have a clear vision after the go-live phase, not just development, and also the vision how could data science project could be adjusted according to the market challenges. For example, retailers who had been trained the models before COVID probably were very, they were very fascinated by the absolutely different patterns of users within COVID times, right? So that's one, example to that. So I have to adjust. And yeah, so as I said, this is slide 11 already. Key points to remember from back. There are just only 4 of them. So first one is data science projects should be realistic. They should pursue clear goal. This is what I mean by realistic, right? Then projects should bring a meaningful business value. And the most important part, you should understand how to measure this value, right? Out of the data science project. Again, data science projects should be simple. In parentheses, I put that ideally, because unfortunately in real life it's probably not always the case, but it's a good exercise to start simple, to start using, to start from simple models and then to progress further. And data science should not be considered as one-time activity, as I stated in the previous slide. So yeah, 12 slides, 15 minutes. So I think I'm even almost on the time. So yeah, that's pretty much it, guys. I would love to answer questions if you have any.
Looks like we don't have a lot of questions in our YouTube channel. However, some questions appear. Does all these parts relate to all data science projects or only difficult ones, like autopilot? To all
Yeah, like autopilot, you're probably referring to maybe Tesla, right? But I'm not sure. So short answer is to all data science projects. The more longer version of this answer, that depends on the project, because sometimes, not always all of these 7 challenges I apply. sometimes only a couple of them apply because, for example, data science infrastructure is in place or communication channels are working fine. But basically, this kind of, an aggregation of the most common problems I was able to identify. But I really think this is not the whole list. I mean, this list could be really, really, really long. But those, if you will do your best to avoid like all the 7 challenges, the chances you will be here could be less. I cannot like promise it because you never promise in data science, right? But the chances could be less. That's an idea.
Those numbers are astonishing. I never realized it. Like 80%. Wow.
Unfortunately, yeah. Unfortunately, it is.
And if you're talking more about project with data science, what do you think? Software development projects and data projects, are their teams different? I mean, in the numbers of developers, QAs, business analysis. What are the specific?
Yeah, good question, actually. Yeah, very good question. So I think about this, data science project could not be done siloed just by data scientists. Data scientists must communicate with the engineers, whether they want it or not, because if they will do all by themselves, training model for a couple of months, then trying to push it to engineering will struggle. So basically, one of the essence and the potential challenge, as I point out, communication. And I have like watched numerous examples when teams were siloed, meaning data scientists on stand-up telling what they have been done, what they will be doing, right? And now everybody listen to them and nobody pay attention because, okay, they're doing something very strange. We don't understand the value of this team, right? And then suddenly after like 6 months of development, they give some kind of a model to engineering so that engineering could put it into production. And here chaos came because that will bring a lot of effort, that will require, a lot of effort from engineering because probably due to the lack of communication all that months, and without any knowledge what have been done from data science part, that creates a lot of chaos. So and yeah, probably I was deviated a bit of your question, but an idea is that a mature and good like a team which strives to success in terms of the deployment of the data science project should work not in the same room. I mean, like virtually, right? They should be in the same team. They should have one, ideally product owner, product manager, like Scrum Master, you name it. But basically, they should have the same information channels, right, to work, and the same information landscape. That will decrease the communication gap, which will inevitably, increase due to the fact that they work in silo. But basically, in terms of team composition, it's data scientists who mostly work with the hypothesis testing, with the data exploration and data validation and so on. And sometimes you can hear, machine learning engineers. Those folks are most focused on the model development side rather than, data exploration, data explainability side. But sometimes, those two are one single person. So that depends very heavily on the project.
And returning to
Hopefully
this,
I answered your question.
Yeah, thank you. To this only less than about this failing data science projects. I mean, only small percent of projects succeed, right? And does it make sense then to spend money to this great infrastructure if a possibility of failure is big? What is your opinion?
Another good question. There is no simple answer to that. It's the same as venture capitalists. They invest $1 million to 10 startups, and statistics there is 80% of startups will die, and then only 20% will live. So basically, but those 20% will give such high ROIs, meaning that those $800 which were lost will be insignificant due to the fact that the ROIs will be high. So here applies probably not the same statistics, but an idea is that, so like 10 years ago, data science was very much about R&D, right? There were no such mature tools and so on. Right now, due to astonishing amount of startups who are, doing MLOps part, data exploration part, data labeling part, and so on, the chances could be low if you do the first steps correctly. That includes infrastructure, but as I said, the good idea is to make it simple, as much simple as possible in the beginning. And if you see the ROIs that your model is performing well, it took you not 6 months to develop, but say 1 month, you haven't invested a lot of effort into data labeling, for example, if you require it, and you, speaking of which, if you have data in place, right, for the first thing first, then you can build on top of that, because good infrastructure could save you money, of course. Lack of infrastructure will increase the chances of failure, but somewhere in the beginning of the project, you can at least highlight how your infrastructure should be built so that it could support the project on scale, for example. But as I said before, I would encourage you to start small, to try really simple models. That will decrease the whole risk. However, I should also mention that data science projects are risky by itself, because before you start the project, before you start the model training, before the model has been put to production, there is no ROI to this model, right? You cannot predict with a 99.999 whatever nines you want to add accuracy that your model will be perfect on the production data. You never know. That's why data science still could be think about, as a part of R&D. Yeah, hopefully that also answers the question.
Yeah, okay. And let's say we've decided to use data science, and you mentioned this problem, lack of data. So how much data is needed, actually, historical data? Could you please, for example,
very
give
good
example, for weather forecasting or some other project? So when do I start?
Got
When
it.
it makes sense?
Very knowledgeable audience. A very knowledgeable audience. So, if you ask any data scientist, he will say or she will say to you that there is no such a thing like lack of data. Give me all the data you have, right? So, okay, there is a potential answer from the statistics, and statistics tell you that sometimes to make somewhat not strong, but somewhat okayish thinking about certain event, you can use approximately 30 data samples. Again, guys, do not I know internet remembers everything, but do not put it that you need just 30 samples to go on. That's not correct. But from statistics standpoint, for some kind of hypothesis testing, that could be enough. Although for data science, I do not think this number will hold. And neither I can tell you how much data you need to solve a particular task, because sometimes for specific models, you don't need much. And then I say much, you don't need hundreds of thousands of examples. You probably need only thousands. But here's the difference. Sometimes you have a lot of classes to distinguish on. Because, for example, class, class of something that means that red, blue, green, whatever, right? If you want to distinguish, number of classes in rainbow, you only have you only have 6 or 7. Remember, unfortunately, right? So that means you will have 7 classes, and those 7 classes should be equally balanced, so that your model will understand where is yellow, where is blue, where is other color of rainbow, right? Here is the same. So if your task demands you to have multiple classes, you have to balance, you have to have enough amount of each class so that model will not be biased towards another classes. Also, actually, you can do the following. You can try some auto ML models. For example, Google had one, and Google, guys, I do not remember exactly, but for specific auto ML task provided by Google Auto ML engine, it was required probably about only 300 of specific classes to learn on computer vision task to distinguish, lung cancer versus not lung cancer, something like that. So for AutoML of Google, that will be enough. But again, do not hold me to that number. That will really depend on the task, on the model, on the data itself. So there are a lot of variables to that into consideration.
Thank you for your answer. Another question from YouTube chat. Melton Smith is wondering, what is the main tool for data science? How do you process data?
Data scientist.
Yeah.
Preserving some work for the folks, right? Well, sometimes you can use ChatGPT. Okay, I'm just joking. So what is the main tool? Okay, as I said, firstly, you start with the business hypothesis, right? However, that holds for the mostly for the product managers, right? Speaking about data scientists, this is the data itself. You, as a professional, aspiring seasoned data scientist, should understand the data to the level enough for you to understand. Can you even okay, so can you trust it? It's a very debatable question, but you should understand how can you work with the given data so that it will be consumed by the model and used with a relative meaningful prediction. What does it mean? It means that first of all, you need to understand the data landscape. You need to understand if there is class balance. I provided an example, or class imbalance. Imbalance, for the example of rainbow I told you earlier about, is that you will have 90% of data in your data set only for one color and 10% for the other colors. That will give your model loose thinking that it will think that rainbow consists only of one color because you provided data to the model only for one color, meaning this 90%, right? The 10% was for another colors. That's kind of a really easy example of class imbalance, which makes very very bad in terms of predictions to the model. So I would put, and yeah, you asked me about the tool. So well, I wouldn't name you a specific tool, but I would name you an approach. This is data exploration analysis. You could do this approach using any tool you want. You can do it through Python, any library. For example, Lux is one of the interesting library I used for the data exploration analysis. Or you can use, for example, R, programming language, also, which has lots of libraries to do kind of interesting visualization and exploration. But data is first, because if you will spend I don't know, 80% or 70% working with the data, that will give you a lot of benefit towards the road while you will be training the model, selecting the model architecture, and so on. I cannot stress that enough. That's something which is a lot of folks they skip this phase. They do not put enough attention to the data, and then they're wondering whether a model looks very very bad, or give really wrong prediction. So that's probably one of the most tedious and probably uninteresting tasks for data scientists, but it has to be done. And right now there are tools which makes life of a data scientist much easier while working with the data itself. Yeah, hopefully I answer your question.
Thank you. There are still a lot of questions, and
Oh,
you can feel pain in these questions. How
I
to
see.
engage, yeah, how to engage business people in project continuation process when all parts are done, but it will need improvements in the future.
Yeah, that's actually a part of go live challenge, right? But potentially. So here's the thing. That depends on the project itself, on the task which has been solved by data science, and the product hypothesis which has been solved by data science itself. I think that if product management team was working well enough, they should have some backlog of product hypotheses which could be utilized by data science team to work on, to make research on, and so on. That's one point to that question. Another point is actually, which I probably avoided, right now I think about it in my presentation a bit. This is monitoring. Model monitoring in the wilds, then the model is in production, is a part of MLOps practice, MLOps approach, but that's another point where you can stress it to the managers, to the any stakeholder. If that haven't been done enough, or if you build a model and you have some monitoring but not good enough or something like that, that's another way or another layer how you can enhance your project, because model monitoring is crucial in terms of, since data itself is not something set in stone, it changes frequently, depending on the task, depending on the domain, of course, but still it changes. Your model have to be retrained on the new chunks of data constantly. This is first thing. And second thing is that most of the time, ML models in production fail silently. You never know that it failed unless you have received a lot of angry customer reviews, or guys from engineering suddenly realize that your model returned from prediction of price of something, it returned 0 or something like that. So that's another angle which could be looked upon. And the last one to that question would be, throughout exploratory data analysis, sometimes you can uncover some really interesting some interesting product insights, based on which you can even create a new hypothesis. But in order to do that, you have to have subject matter experts in place, or at least someone with whom you can consult about it. And in order to avoid challenge I told you about, if you just start the project with the data without even understanding what this data does mean, that's the reason why subject matter experts are really helpful here. And I know a couple of projects where data scientists were intertwined together with the subject matter experts, and that lead to really promising results in terms of data science project outcomes. So yeah, that's another one.
Yeah, I think there are enough reasons to go on with the data science project. And another question is there a right approach to give data science access to personally identifiable information data and not to violate GDPR? Is there a right approach to
Yes.
it?
Actually, we at EPAM, on the right of marketing, right, do have projects which will do this kind of stuff. They will de-anonymize your data. Not only EPAM does have this product, but also other companies as well. So basically, yes, there are but there are numerous techniques how can you anonymize your data before a data scientist will touch it. Basically, if you speak about US, you cannot touch PII without, I don't know, thousands of NDAs and so on. It's very tricky topic. And yes, PII should be anonymized before it reach any model, before it reach any exploratory data analysis. Even more to that, there is a part of responsible AI here, which not only take into account PII data as a personal identifiable data, right, which is very confidential by its nature, but also how the model will treat those minorities, right, in order not to use any features, but it's only part of responsible, right? There are different angles to that, but basically, in order not to use any features which could discriminate people, such as age, such as gender, such as skin color, such as nationality, and so on. That's another very important topic which somewhat connects to the PII, but not directly, right? But still, it's also important point to take into consideration while model training and while data exploration as well.
Thank you. One more question is, can you elaborate on the role of the data science product owner? How does it differ from a typical product owner?
Well, another good question. That really depends on the project itself, because sometimes, data science product owner could be think as a technical, like product manager, technical product owner, who is who is enough versed in the data science concept in order to distinguish, supervised models versus unsupervised models. When do you need to use deep learning? When do you not need to use deep learning? Spoiler amount of data, right? And that's it. This is my personal view on this topic, because the role of data science product owner or machine learning product owner is very new to the market even now. There is no, kind of proven job description to that. But my personal opinion is that product owner should be, again, well versed in the data science concept enough to be talking to the data scientist on the same language, to understand why data scientists use this metric, and what does this metric mean. I mean, loosely speaking, right? You do not need to calculate that metric. If you want to go one step ahead, you can train yourself enough to be able to create proof of concept of some ideas, again, using Python or R, well, probably Python, right? And to check if the given hypothesis even works out using data science or not. But that's something which is not very, often you can find on the market. Basically, I would opt for understanding data science concepts firstly. Secondly, understanding metrics, which were used for the specific algorithms, right, and for specific models. And most importantly, as I said in the beginning, how will you translate the model metrics to the business metrics? And that alone could give you a lot of advantage. If you can do that, you can, you don't need to know how to do Python code and so on. That will alone give you a lot of advantage. That's my point of view.
Thank you, Nikolay. We have some, funny question at the end. So, what is harder, rocket science or data science? For the
Elon Musk
finishing of our,
Elon Musk entered the chat, right? Well, rocket science, of course. It's no way to think about it. At least in rocket science, you can. Well, actually, not. You cannot promise anything. So, yeah, good question. I would opt, even though I am data science fan and so on and so forth, I would opt for data science. Come on, you're building ships to go to the Mars or whatever. So, yeah, data science is a tool. Actually, one more important part about thinking. Well, to my mind, correct thinking. Data science is just a tool which supports product. In my way of thinking, in my universe, there is no data science without a product. Unless you're speaking about Google, Meta, any other huge corporation which could pour millions into R&D, right? But basically, I think about data science as a tool which supports the product, which helps product to reach more audience, to reach some meaningful business results. That's why, I named the presentation Business Challenges. But it's my, again, way of thinking. It's not necessarily correct, but it's much easier for me as a product to think about it in this direction.
Well, thank you very much for your presentation and for your answers. That was a very interesting talk. We are glad to have you.
It was interesting questions. Yeah, those were very interesting questions. I really even sweat a bit on some of them. So yeah, that's cool. Thank you so much.
Thank you everyone for watching.